My name is John Arvig with Campbell-Sevey, and today we're going to look at these 800 TVS steam traps. And these traps are a little bit unique from what you've seen in the past. A standard inverted bucket trap is this cast part right here. And the unique part about this is we have cast-in isolation valves on the inlet and the outlet. And then if you look at the bottom, this right here is a strainer also. And then at the bottom we have a strainer blowdown valve. So what we would typically do is the steam comes in this direction, goes through the strainer and then into our trap, and then out right here on the discharge. And if we're to maintain this or work on this trap, what we would do is we'd isolate this piston valve, we'd isolate this valve, and now we can potentially work on this. Now we still have pressure built up in the trap, so then we would typically blow down this strainer, or this strainer valve. The other thing that we can always do is off of this port is downstream of the orifice. So if a fitter were to want to test this valve, or this trap, we can isolate the downstream side and leave the upstream side open, and then this port we can run to a drain and do a visual test. One other reason why we really use these quite a bit is the end-to-end dimension from here to here is identical to that of a standard bucket trap. So now instead of needing a 6-foot or 5-foot long length of pipe with all those isolation valves and strainers, we can do that now in a little over 5 inches. So it really simplifies things. And also, without all those nipples, the pipe nipples, you have a lot less leak points too. So that's the 811 TVS trap in a 1/2 inch up to 1 inch, and flows up to about 2,000 to 3,000 pounds an hour.